schools, you have some projects also?
Yeah, there's science fair, which is basically you have teams, and with those teams, you either do like experiments or engineering projects, and then it's like a competition. So you compete. Whoever has best project goes up in level.
Very good, very
Yeah.
good. See, I have the engineering background, basically, and robotics in particular. I happen to be the president for Robotics Society of India, which I had founded in 2011. So I'm in touch with most of the guys in India, in all IITs who do research in robotics. And robotics is very, very popular. Almost everybody wants to do robotics actually. Uh, what I thought for you guys in this age group before coming here, and which I have seen also being implemented successfully, perhaps you can think in terms of buying out a 3D printer. Have you worked with 3D printer?
Yes, we have.
You have at home?
Yeah. Not at home, but in school there are multiple.
So there are many versions of it. There are some kids versions, and grown up. A particular one for your age group, maybe any cube model costs around $200 to $300, and sometimes they bring down the rates also. Some deals are available. My grandson in California, he's 12 years. Last few months I was there before coming here, so he bought one on my recommendation.
$300.
$300. A 3D printer which runs on plastic material, is a film of plastic which will melt and deposit,
Yeah.
and you can make a product. You have to feed the design on computer. Already they give you few designs which are proven to work there. Plus you can innovate on your own designs. That's still more interesting. And you see something happening, shape coming out layer by layer. So that's very interesting to see that really you can really make a product. Uh, be,
Last year I had taken a course actually for like aeronautical engineering. So like all like air, flight, and like all that. So for that I had used 3D printing to make like handmade rockets out of small cheap materials.
Yeah. See, the 3D idea can go very far. This is only a beginner's thing. Finally, you may be knowing if you have taken interest. 3D printers can do anything, right from making small things to even making this full house to making an air. You can make an. Actually, there was a time when these technologies were not available for use in public because you can make some of the defense equipments using 3D printing. So, and from medical also, whatever goes in the dental business, it can all be done with 3D printing. You can make the teeth and the whole thing also. I mean, you just do the 3D scanning of the thing and put it in the computer, and that full product will come out finished. So, and no machining involved, just layer by layer keep on depositing. There are many other technologies. I somehow had contact with most of these things because in India what happens, we have to do most of the things on our own. We are not having access to some of the technology from other countries. But the advantage was that by being on your own, you really learn right from fundamentals, and you try and you fail initially and then you succeed and all that. So finally you get a confidence. Then with that confidence, though I was with atomic energy, but we could help many other departments of the government, defense department, medical, and so many things, DRDO and NIO. There was a robot which goes in the sea, it does trials around Goa waters. So many things were done successfully. But anyway, those things we can talk about later on. But I think today's thing is, I will recommend, of course, you can always get back to me if I have your queries, doubts, or anything as you go ahead. Basically, I am looking for some beginning that you get into something. One is that you think, if possible, you think of having your own 3D printer, a suitable one. There are so many models available. The idea being that
That's the cost, and what are the consumables? How costly?
consumable is not very costly. They will give a big filament bundle, a roll, which comes along with the machine. That itself may last for 6 months to 1 year, and later on for $50 you can get another one like that. The idea being that see, one is that you will be able to improve upon your computer knowledge when you program and all that on your own, and you after initially trying out the design which they give you, then you will try your own design. When you try your own design, then a lot of innovation has to be done, and you see the results, and you will see that if you make a mistake, then what happens, and how to improve upon it. And finally, you will be able to make very innovative products. And if this same business goes on higher, there are much bigger and bigger 3D printers. Full carrier is available, and there are 3D printers which can handle cement, which can handle metals. You can make a metallic product. This will be plastic for you. It will be plastic. Yeah. So only little care is required. You must have you already done it, so that some fumes come out from if it is too hot or something. So you don't put your hands there, but that much in this age group that is not a problem. My grandson, 8 years old and 12 years old, they are doing it every day
At home.
at home.
Wow.
8 year fellow is also doing. That 8 year fellow does better than the 12 year old because the interest is more. No? So he wants to show also that he can do better. So I don't see any problem in that. You think over it.
So there were some plastic chairs at New York airport with that wheelchair. We were told this is a 3D printing.
Yeah, it's possible.
product.
It's possible. Anything, I mean, so many things are possible. I actually had some things done by our grandson. I didn't bring in a hurry. Fantastic thing. So many things you can make. See, one example I tell you, that you have this chess board, no? There's so many those things are there. So some part was broken, damaged, then the king or something. Then that design he himself fed in the computer, and the real thing came out.
Basha bana liya.
Absolutely. Exact one. Anything is possible. The idea is to learn how to do it, and particularly if you have inclination towards engineering, innovation, robotics. See, now what he is doing is he feeds a design of a robot. This 3D printer will print out some basic parts of the robot. Now, then some parts you can buy out also, like wheels and other things, and then you can assemble it also. So finally, if you can make a robot of your own, half of it done by 3D printer, half of them you have assembled using standard parts. I mean, like that, there's no limit. You keep on doing it. So finally, you feel very happy when the full robot comes out. See, instead of doing by Legos and all that, you make it by 3D printer. Most of the parts, some parts which are standard available, you can buy out also, assemble them. And all that. So that is one idea. The other thing is to keep you aware of what all is happening in robotic research. It's a very high research subject everywhere in all countries. And fortunately, this subject of robotic research is open. The information is easily available. You don't have to spend money on that. Freely, online you go, you can search it. Anybody who is doing it, because people who are doing it, they are interested in publishing that I have done it, I have done it, I have done it. So in the process, it is openly available to everybody. It's not a hidden research or anything.
This face mask for the COVID protection in our university, this was being made out of the 3D printer.
Yeah, it's possible.
It was a big news then 3 years back.
Many very complicated things are possible. That is why this technology was denied to many other countries, because people should not misuse.
Where was it invented first?
USA.
USA.
I think Da Vinci people there in California, they invented it. I think. Anyway, we talked about Da Vinci. Da Vinci is the only company in California which make a surgery robot. A robot which does surgery. By laparoscopy. You make only 3 holes in the body, 8 millimeter diameter. Through one hole, one right arm goes with tools and all that. Other hole, left hand arm goes, and the central hole carries a camera equipment. Through camera, he gets a feedback The doctor is sitting somewhere else. Doctor is not doing it. Robot is doing it. And the doctor comes to know from the camera image gets 10 times magnified and the mechanical movements get 10 times reduced. Whatever doctor moves by 10 millimeter, actual movement will be 1 millimeter to be on safe side. So that is how that surgery is done. And interesting thing is that even for doing heart things, so-called bypass heart surgery, you don't have to cut the ribs. Without cutting the ribs, it can be done. That is very good because the patient is back to normal in 2 days instead of so many days.
After heart surgery?
Heart surgery, after 2 days you are all right. Because there is no cutting, no. So this I have seen myself, this operation in Escorts Hospital. There used to be only one guy in India, he was doing it, Dr. Trehan. Now he has his own hospital, Vedanta Hospital.
In Gurgaon.
Gurgaon, a very big fellow. So he called me to show me. Normally, you are not supposed to enter that place, operation theatre, when they are doing it. But because of a research connection, and his teacher wanted to show me actually. One professor from IIT Kharagpur, he wanted to show me. So he told this doctor that I want to show to Manjit Singh. He says, you bring him, but tell him to come there by 9 o'clock when operation starts, and he should dress up like a doctor himself. Because he has to show to the people that nobody else has come there, only doctors have come there. So he gave me his own dress and I put it on.
Camouflage the doctor.
So to show me basically. And then when I saw it, I saw that the right hand arm and left hand arm, this is the same thing which we are doing in our nuclear reactors for handling materials. We call them master slave manufacturers. We don't call them robots. The robotic world itself came out in 60s, I say. Before that itself, we have been making those things which today they call robots. We used to call them master slave manipulators.
Master slave
Master
manipulator.
slave manipulators. Sometimes if you're in India,
You're familiar with master slave manipulator? He's been always talking to me during morning walks, but I never understood it. Do you understand?
I tell you, see, this best robot is the human arm. Human arm has 7 degrees of freedom. X, Y, Z, you know. And rotation around X, rotation around Y, rotation around Z. So 3 and 3, 6 axis, 7th axis is gripping. So these 7 things are possible by human arm. Any robot, ideal robot, will be able to do these 7 things. So we make a mechanical arm which can do these 7 things, right hand and left hand. And the master part is in the operator's hands where he can manipulate the arm. That slave part replicates those things. So if I have to handle a material, radioactive material, in radiation area nobody can go. So because atomic energy deals with radiation, and it is a success only because of this remote handling, what you call robotics now. So we have shielded rooms. Shielding is 8 feet thick concrete shielding. 8 feet thick, 140, 305 millimeter. So, and we have in the cut like a door size, a big cutout of a glass window. It's a lead filled glass. So 8 feet thick glass is there. Through glass, we can see what is there inside it.
It's so transparent?
So
Okay.
that glass is very special. We make it because normal glass with radiation will become yellow in no time. So it's a very cerium doped glass. We make it at CGCRA Calcutta, that is Central Government Lab. So through that window you see, and this master operator will manipulate the way he has to handle that the slave thing has to handle, and he will manipulate here and it will be replicated here. There's a mechanical. This was the success story of atomic energy anywhere in the world. Otherwise, atomic energy things cannot be done if you are not going through this. Now, later on, we have more advanced versions of it. That mechanical thing is replaced by electrical. Master and slave are separated. Master is somewhere else. All those things are, and later on, even computer becomes master. So but the starting thing is this. So when I saw this with Dr. Terhan, I told him that is master slave is a master slave manipulator. What you are doing, what you are calling a surgery robot, and we already have this technology. Only thing is our slave arm itself is very heavy one. We are handling 30 kg of radioactive material. You are only doing cutting something and stitching. Only 4 axes you need. We need 7 axes. So it's very simple, and I can make it for you. So he says how much it will cost. In government, we work for government now. So we don't look at the cost or anything. So And we had no dearth of
Plenty of money, tons of money.
So, and not personal money, government money was spending. For personal money, we never, hardly anything. It's good enough for living only. So, I just like that, I told him maybe 1 crore or 1.5 crore something. He had,
1 crore is 10 million.
Yeah, I know.
he had bought at that time for 20 crores at that time. That was in the year 2000. He had bought it. So he said, if that is the thing, so much, then still only 3 hospitals have that in India. And they are using it only for VIPs and all that, not for normal people. It's so costly. In India, it's so considered so costly. So he says, that is the thing, you design it, you make it, I will set up a factory and I will manufacture and sell it, and then I will make a lot of money, then I will leave this medical profession. He was the chief fellow there. Then I will, because he was so money minded person, that I knew. Then I told him, we don't do like that. In India, we are government people. We develop the things and we make them available to public at a low price. That is our purpose of developing. We don't make money out of it. Then he says, that is the thing, I am not interested in talking to you. he ended the story there. I mean, I'm just trying to give you the sort of example that robotics and these innovations can take you anywhere. This is one area where you can think over in case you want to do, and you search online, many things you will find.
Are you saying they can make huge money in robotics?
Yeah.
Okay, that's important.
That was important. Yeah. Because there is a lot of innovation. Robotics is still having a lot of research component, still having, and people are doing day and night, and whatever there's a big advantage in doing in America compared to doing in India. There's no doubt. I have no doubt, because here whatever you do, many related things, inputs and all that, you will be able to get easily, and of a very high standard, quality and all that, matching things. In India, it's difficult actually. And so you can come out with the final thing, and you can try it all and all that, and you can depend upon some other people also who have to do some part for you and all that. It's totally dependable type of thing. Very, very seriously it is taken here. Things in India, you may be doing excellent, but then you may not find a second fellow who will also be interested. You alone may be doing it, and you may not get everything what you need also. And even if you get something, it may not work also. So all those problems will come. Yeah, I think you think over it. If you are already having interest in engineering and robotics and computerization, I think there's nothing like it. And if you can have one 3D printer at home, then you will keep on trying your innovations, and it will keep you focused on that kind of thing. And compared to many other technology, this is easily doable and workable at home itself, and not very costly also. It's a little costly, but not that very costly. One can afford it, and it will give you a platform to really try many things, and keep on trying.
Will they be able to generate some money if they buy a 3D
Yeah, it's like
printer?
this. If your school
Will they have some projects to do?
Yeah, your school, I think you can frame a project based on that. What our grandchild is doing there, the 12 years old fellow, his school liked it so much, they have made a team around him of 15-20 students, and he is leading the team, and the school is funding some products which will come out of this. So he is doing that.
So you're happy? Great ideas? Something to buy and something to have fun, but keep it secret.
Anyway, this is only a sort of beginning. What I request is that, more than you, I am interested. This is like this. So you keep on, you can ask me anytime, anything. You can have my email ID. Some queries you may have while doing this or any other, particularly anything related with robotics or engineering. If you have something to ask, I'll be too happy to help you out. I can give you many of my own publications and Indian publications, anything, but that may not be really needed by you, because you are already in an advanced country. You already have access to.
Manjit, could you tell them about the nuclear medicine?
Oh,
Because
yes, yes.
this word they're not familiar with. What's nuclear
Yeah,
medicine?
yeah, yeah. See, one of the methods of treatment of cancer is by injecting radiation, nuclear radiation, gamma rays, high energy gamma rays, into the cancerous portion which you locate with the body. So first job is through 3D X-rays and all that to confirm where is the tumor getting formed, localized, and what is the shape of it, size of it, and where it is located and all that. That is by one machine, 3D, three-dimensional X-rays and all that. And then our machine, what we call Babatron,
What's the
is
name?
for is Babatron.
It's named
Babatron, with the
after
name of Dr. Baba who started
the
Babatron.
famous.
We are so proud of it, so
He
the
was
name
the
is given Babatron.
first Indian scientist. Nuclear.
So that machine is, for us, that machine is also a robot only. Okay, it has many degrees of freedom and all that. So it will send a very pinpointed radiation coming from a source, cobalt 60. Cobalt 59 is naturally occurring material which we irradiate in the reactor and make cobalt 60. Cobalt 60 emits two types of gammas of some energies, and those gamma rays will go. You first determine where is the tumor portion by one of our machines, a sister machine of Powertron, and then you put them on the patient on the Powertron with the degrees of freedom and all that. You send the beam, radiation beam, into the tumor portion. If you do all the precision job and all that, that tumor will absorb the radiation, get heated and die out. Over, finished. That is the way of treating.
But if the tumor is inside, it will have to penetrate part
Yeah,
of the body.
it's like this. Radiation is coming from outside. It's called telescopic outside and going there. So you focus it. There is a focal point. No?
Yeah.
So radiation is coming and getting focused onto the tumor. The focal distance and all that are adjustable. So you focus it on the tumor. Still, whatever you may do, even with the best planning and all that, some healthy tissues around the tumor on the boundary of it may also get dose, which is not required actually. It should not be there, but one may get it. Then to minimize that, what we do is we don't give them total dose for killing the tumor in one sitting. We give in 10 sittings. In one sitting, only some part of it, so that the healthy tissues do not get much dose. And how the nature has built the system, human body like that, it is seen that a small amount of dose, even going to healthy tissues, is also not harmful. You are, in any case, all of us are getting radiation from sun all the time, and it has been going on for billions of years. What is sun is emitting is the same radiation. All of us are getting, but we are getting a very small dose of it. It's measured to be 0.025 mR per hour, milliradian per hour. That type of dose you are in any case getting from sun. A very small dose is not harmful. Not harmful. But higher dose can create problem. No doubt about it. It can actually cause tumor and it can cause cancer. All those things can happen. So we control it by many sittings. Every sitting you give only a small dose. Focus it properly so that healthy tissues don't get it. Then give a 1 week time. Some of the healthy tissues which got some dose, they will recover. Healthy tissue means that only, that it will recover. The tumor means it's not recovering, it's only spreading. It's dying only. So they will recover, and this is a proven technology. Now we have our own machine doing it, we call Babatron. Earlier, our machine is there since 2004 when Manmohan Singh became Prime Minister. We have put the first patient, he came and inaugurated the machine. After that, India has not imported any machine. Otherwise, all over the world, all these machines are imported.
How costly was the machine imported?
All these imported machines come from one place called Theratron Company of Canada. That company is called Theratron, that is why we call Babatron. So, at that time, in the year 2004, India already had 243 imported machines, no doubt. What is our connection with these machines is that radiation source, which is giving radiation, that can come only from BARC in India, from atomic reactors. In nuclear reactor, cobalt 50 we put and becomes cobalt 60 gamma emitter. Source we were giving to all the hospitals, even for imported machines. The machines were imported. Now after that, now our machines are also ours. Source in any case is ours only. So that time we were able to give this machine in India for 95 lakhs of rupees, little less than 1 crore.
95 lakhs means how much?
Or little less
10
than
million?
1.
10 million?
Yeah.
10 million rupees.
So a little less than 1 crore. Today, our machine will be costing 3 crores because material cost goes in.
30 million.
At that time when we were giving for less than 1 crore, imported was 4 crores. India is a little poor country, so India, many districts do not have even a single machine. Then we wanted to popularize it, but then India, a lot of corruption in government thing, lot of problem. Finally, how to popularize it, we got one day an idea that Director General of International Atomic Energy Agency, Vienna, which is a sort of watchdog for all nuclear things all over the world actually. They're very powerful people. So that Director General came to BRC for something. So we showed him our machine. He was so happy. Our machine has been certified nationally and internationally right from the beginning. The certification comes from Canada only. Canadian company does certification. So we had got it done. So he gave us the idea that all developing countries are a partner with the International Atomic Agency and we have to pay money to keep our partnership with them every year. So they say that he says that you give these machines to other developing countries who cannot manufacture on their own and they are also poor, they cannot afford imported machines and all that. And you don't pay us your contribution for IAEA, we will adjust in that country.
But do charity to the poor
Charity.
countries.
So in the name of IAEA, we give it. So like that, we have been giving machines to other developing countries also.
So total how many
Total by
places
now
you-
we have some. I can give you a video on that. We have say 100 machines in many places, 60 in many other countries and other in India, and it is growing like anything. And I had inaugurated the first machine abroad in Vietnam in the year 2008, I think. Yeah. Vietnam, they were using our machine round the clock. Doctors come in 3 shifts instead of patients coming. Doctors are there 3 shifts. Because normally we have seen in our hospitals, at least in India, doctor will come for 2 hours, 4 hours maximum. There, doctors are 8 hour shifts, 3 shifts. Doctors are coming. So many patients are lined up. So when we go back and see, we feel very happy. Then later on, I got a chance to inaugurate these machines in many other countries: Sri Lanka, Namibia, Uganda. Nowadays, our new Prime Minister Modi himself does inauguration. He has done in Mongolia, Kenya. He is very happy to do himself. He doesn't call me. I used to go myself.
he was doing it. Now the Prime Minister does
So
it.
it's okay. That is a politics
Sir,
part of it.
what's the treatment cost?
Oh, treatment. We say we normally
Per day?
half of the machines we have donated, half of them people buy it also. The treatment is very simple, not very costly. See, it depends, the cost depends on the hospital, their overheads and all that. Even in our own hospital, in India, the Tata hospitals are considered the best for cancer. Public doesn't know that Tata hospitals are our hospital, Atomic Energy.
They're not of Tata.
They are not Tata.
Name is
Out
used
of
for
respect,
out of
we call it
respect for
Tata
Tata.
hospital because the first cancer hospital in India was set up by Tata, earlier Tata, in 1927. Later on, it was transferred to BARC. So today, all Tata cancer hospitals are BRC hospital, our staff, but we still call them Tata hospital out of the respect that we have for them.
And what are the costs, sir?
Yeah. So treatment cost is, say it is like this. Even in Tata hospital, what we have different slabs. The people who can afford, for them the rate is different. People who cannot afford, the rate is different. People who cannot afford at all, it is free of cost also. So it depends on the hospital. I recently went to Lucknow. I had inaugurated one machine there. Recently my wife and myself, we went there for some other marriage. So I told her, I'll show you our machine. You come with me. So we went to hospital and so I asked them, what do you do with our machine? They showed me the register. They were treating 80 patients per day and charging 25 rupees.
Less than 1/4 of a dollar, nearly 1/3 of a dollar.
I was so happy. I had given them that machine long back and they called me to inaugurate it along with the governor there, and also they asked me to address the students who were passing out on that day, convocation test. So we were very happy to see. Still I asked them, is there anything else that we can do? They wanted some more accessories and all that. So then I told them,
So how much the treatment costs here in USA?
I do not know. But see, USA has got still more sophisticated machines. We also have that are called electron beam machines and all that. There, because here people do not know, they have access to higher technology, so they do not want to handle radiation source actually. This cobalt, for imported machines also, why India was making source in our hospital, because source they will not like to send from by air and all that. Though we have methods to send, we have sending, but they will, and also source has got life for half life of 5.3 years. Any radioactive material has got half life. After 5.3 years, the strength will come down to half. So after that, it is not so much useful for
How is the source traveling to different
yeah, so
hospitals?
we have a flask, radiation flask, shielded flask.
No. How
Which
big is
the
that?
flask is a 2 ton flask.
Oh,
2 ton flask.
2 ton.
Carrying this much source, 2 ton flask is there. And the flask has to be qualified for if the flask drops from air also, nothing should happen to the source. If it drops into the sea also, nothing should happen. If you put the flask into fire also, nothing should happen. So we have a qualified flask. For Vietnam and many countries, we send along with the machine a flask also. Because for doing any maintenance on the machine, you have to first take out the source from the machine. The source has to be then kept in the flask. Source cannot be kept outside, just like that. So source is handled by.
So in any major earthquake or tsunami, there is no danger to this source and
These
the
are the proven thing. Already this technology was proven.
they're safe.
So I think the main question was that in US and all that they have got access to still better technologies, but very costly. See that electron machine which does not handle this radiation, only electrons will do the treatment. High energy electrons you create and all that. But those machines are very costly for India. For US it's all right. But the slight advantage is there that that healthy tissues will get still less dose. They will not get so much dose, healthy tissues. But what we have done, some great innovation, that's why I insist on innovation, that in the front of our machine we have 40 leaves of tungsten, 2 mm blades of tungsten. So we create a shape of dose passing through the beam, tungsten. The tungsten is for absorbing the radiation which should not pass out from there. So you can control the shape and all that. To generate a shape of the beam same as the shape of the tumor, so that the healthy tissues will not get it.
Manjit, I have one request to you. You will give them some projects on email, give them material. They will do their project, submit to you, and you will be their mentor. It was an icebreaker today, and the process will go on. And our target is to create more Manjit Singhs, and we want them to be 100 times more superior to you as a technologist
But
and engineer.
just go through that video of our Babatron. That I will. You
You-
have it. I have given to you.
Yeah, I will pass on to them. You kindly send me, and I will pass it on to them. How much time you have before your next assignment?
Oh.
Because
But you
right now, how much time we can spend more today together with him?
Not much.
So
It's
10.
5:50. 10 minutes.
10 minutes, fine. So we wind it up now, but you will be in touch with him. आप यहाँ पे कब तक रहेंगे?
15th November we are going to California back.
So he will be accessible to you.
Yeah.
And you three decide with who are the other friends with whom you want to share it. If you don't want to share it, don't share it.
See,
Let
so
it be your copyright,
See,
this knowledge.
My concern is very simple. If any good thing comes out of it, fantastic. I'll be more happy. But one has to explore, keep on trying something. If I cannot help you myself, I may be able to.
You'll
you
put them in
across
touch with others. And I told them that you will put them in touch for biotechnology
Yeah.
and robotics and nuclear medicine. These were the three. Any other fields which you think are the hot fields for future where their
So I
careers could
think
be?
once we do some correspondence, mutually.
Yeah, they can have what I
can pick
suggest.
up. Today I came with my own idea.
Sir, we can have, they can fix a Google Meet with you when you've gone to California, and they can have regular contact with you. And
Absolutely, no problem.
so now I'm handing over them to you, and you are the mentor. because they will take you more seriously. Normally, they don't take me that seriously. But I'm very glad that there has been a meeting. And sir, गुरु जी को कुछ तो खिलाना है ना.
Please have.
So any questions or
At this point of
anything
time-
you have to say?
This time, no.
And when is the 3D printer being bought?
Ask Mama.
Okay.
We
I-
have it at school too, so we can just use the laptop.
Yeah, there's a lot at school.
You have them at school. Okay. And are these sort of projects which you talked about being done by students in school in routine?
We did
Already.
smaller projects in class. Like I took engineering last year.
It's like a class itself
Yeah,
to
we
teach you
did.
how to do it, how to build things, like use your
The
creativity.
idea, if you have at home, now then you have all the time.
See, my idea of this interaction was there are all students are good. We want you to be very, very good, so you got to do something extra. And somebody very good has to initiate you. So if you have a guru who's better than other gurus, then you are better students. There's a very tough competition in the students these days. And here everybody is working very hard, all these 500 families. So you have now an extra guru, and he is distinguished scientist Manjit Singh. And I have a relation with him. He was, you were born in Patiala too? We are both Patiala born people from Punjab. And I, by chance, ran into him one morning during a morning walk, and I could identify that here is a man who could teach me something. And this winter came in the way. During the severe winter in the morning, we could not meet. But yesterday, I went to his place after lunch, telling him that I'm going away day after tomorrow, and we must have a meeting with our kids. So this is recorded for you, and